Everybody. All we're going to do in this video is graph the parent functions of sine theta, cosine theta, and tangent theta. And everything that you need to know about the graphs of these functions comes from the unit circle. So always keep that in mind. Get out a unit circle as you're watching the video, and that's the key to understanding the graphs of your trig functions. Alright, so the sine function has its zeros at the multiples of pi, and we know that because we know the unit circle. Sine 0 is 0, sine pi is 0, sine 2 pi is 0, and it has its maximums and minimums at the odd multiples of pi over 2. So the sine of 1 pi over 2 is 1. The sine of 3 pi over 2 is negative 1. And if you loop around the unit circle multiple times, 3 pi over 2, 5 pi over 2, 7 pi over 2, that's where the sine function has its maximums and minimums. So we piece this together, and the graph is as follows. So I'll put in the zeros of the sine function first. So at all of the multiples of pi. So 0 is a multiple of pi, pi is a multiple of pi, and there's not enough room to get 2 pi. 2 pi would be over here. Negative pi, that's a multiple of pi. Well, between 0 and pi over 2, that corresponds to the first quadrant of the unit circle. So at pi over 2, the sine of pi over 2 is 1. So we have our first maximum at 1. We come back down to the X-Intercept, and then at 3 pi over 2, we're back to negative 1. Now if I repeat this, the sine of negative pi over 2, well, negative pi over 2 is the same as 3 pi over 2, 270 degrees. So at a minimum, the sine is negative 1, and then we follow the pattern. So I have all of these dots, and now I connect the dots the best that I can. It's kind of difficult to do with my pen program. I can do it a little bit better by hand. So just do your best. Try not to cross the X-intercept like up and down as a vertical line. It actually crosses at a 45-degree angle. And then we go to its minimum and then back up. I know the graph doesn't actually go to 2 pi, but I want to finish that because this is called one period of the sine function. The period of the sine function, I didn't write this beforehand, is 2 pi. That's the width of the interval where the sine function has all of its features, and you just repeat this process over and over again. So if I were to go over to negative 2 pi, which would be about right here, I would just have to draw the same picture again. And like I said, this is kind of hard to do on a writing tablet, but I repeat the same thing. I just connect the dots. So that is the graph of the sine function. And again, all of the major features come from knowing the unit circle. So let's move to cosine. Now I want to keep all the information on the right side of the screen, so give me a second to delete everything with my eraser. Take just a second. And now let's graph the cosine function. So here's the features of cosine, and again, you get these by knowing the unit circle really well. So the cosine function, the cosine of 0 is 1, the cosine of pi is negative 1, so the maximum and minimums occur at the multiples of pi. But what about the zeros? The cosine of pi over 2 is equal to 0, the cosine of 3 pi over 2 is equal to 0, and extrapolating, that means cosine has its zeros at the odd multiples of pi over 2. So let's start in the middle of the graph. The cosine of 0 is equal to 1. And then we get to an odd multiple of pi over 2. Well, the cosine of pi over 2, that's 90 degrees, is equal to 0. And then we're going to go to the minimum. The cosine of pi is negative 1. We come back to the maximum. And if there was room, 2 pi would be about right here. The cosine of pi over, the cosine of 2 pi, we're back to 1. And then you connect the dots the best you can. Again, try not to cross at a vertical line because it's not a vertical line. Looks like I'm doing a little bit better on this one. So that's one period of the cosine function. Now since we have enough room, we'll do the same thing. So at the odd multiples of pi over 2, cosine has zeros. So negative 1 pi over 2, negative 3 pi over 2. So the graph is going to come down to its 0, and then we're going to continue down to a minimum, then we turn around, come back up, and again, if we had enough room, negative 2 pi would be about here. But it's the same thing again. The period of the cosine function is also 2 pi. So I have one period graphed. Now let's graph another period. Same thing again. Do the best you can drawing the picture. They're kind of hard to graph. But there we go. We have two periods of the cosine graph. Now, if you compare this to the sine graph, sine and cosine are very, very similar looking. It just looks like they're shifted left and right a bit, more or less. Again, give me a moment to erase this graph. I want to keep the information on the right side of the screen. And now let's graph the tangent function. Now, the tangent function is significantly more complicated. You want to think about the tangent function as sine divided by cosine. If you think to what we know about rational functions that we covered in the first semester, anytime the denominator equals 0, the graph is going to have a vertical asymptote. So here's the chain of logic. Well, where is the cosine function equal to 0? Well, we know that from the unit circle. So at all of the odd multiples of pi over 2, the graph of tangent is going to have a vertical asymptote. So I'm going to draw a very light line. If I was doing this with pencil, I would make it a dotted line. That might be hard to see on the computer. So I'm going to draw dotted lines here for the vertical asymptotes of the tangent function. I have to do this at all odd multiples of pi over 2. All of these odd multiples will have a vertical asymptote. So this function has an infinite number of vertical asymptotes. Every time you hit an odd multiple of pi over 2, you have a vertical asymptote. Okay, now, what about the x-intercepts? Well, again, think about what you know about rational functions. When you want to find the x-intercept of a rational function, you set the top equal to 0. Now, this is not actually a rational function, but it has some similarities. So the chain of logic is, well, the tangent function has its x-intercept when the top equals 0. That's when sine equals 0. So that's when you're at a multiple of pi. So at 0 and pi and negative pi, the graph has x-intercepts. Now, the period of the tangent function is pi. It's not 2 pi like the others. So between any of the asymptotes, the width of this interval between the two vertical asymptotes is pi. So this is one period of the tangent function. All right, so let's further divide that. Between 0 and pi over 2, that corresponds to quadrant 1 of the unit circle. Whereas negative pi over 2 to 0, that corresponds to quadrant 4 of the unit circle. And now use the all students take calculus mnemonic. Between 0 and pi over 2, since that's quadrant 1, the tangent function is positive. So you know the graph has to approach positive infinity on the left side of that asymptote. And then tangent is negative in the fourth quadrant, so the graph approaches negative infinity in the fourth quadrant. And now since periodic functions repeat the same behavior over and over and over again, I don't have to think anymore about quadrants. I just copy this picture in every period. And remember, the period of tangent is pi, so between any two adjacent asymptotes is one period. So I'm just going to copy the picture in the middle again. And there we go. So depending on the size of your graph, you just repeat this over and over and over again. And we have a little bit more room here, so I could actually draw, let's see, 2 pi would be about right there. That would be the next intercept. So you can draw half of one of these periods if you want. 2 pi would be about there. And I can draw another half of the period. Now, if we were to graph the cotangent function, you would do this in exactly the same way, but you have to think about where the zeros are and where the vertical asymptotes are, given the fact that cotangent theta is cosine over sine. So the shape is very, very, very similar. And you don't want to try to memorize all of these things. There's just too many graphical features when you're looking at the trig function. So you have to connect this all back to the unit circle and think through how you come up with the locations of all of these properties. Anyway, that's the video about just the parent functions. Hope it helped.